All right, let's start this lesson with a diagram that we started with in the beginning. Now, we already did the topic of algebra in this section. So now we're going to go on to our new topic, which is quadratics. The first thing that we need to learn about when we're doing quadratics is completing the square. Now, today's lesson is going to go a little bit longer and well, longer than usual, and it's all about making sure you have all the information with regards to quadratic equations. All right, so this lesson is called completing, just write that out, completing the square. All right, so let me start off by saying that you already know about quadratic equations. All right, we already know about them and we already know how to factorize them from lesson 5 where we factorize quadratic equations. Now, when you graph a quadratic equation, they usually tend to form a parabola. All right, and a parabola is nothing more than a U-shaped curve. And the U-shaped curve is either going to be facing up or it's going to be facing down. And there's a particular condition for which you determine whether it's going to face up or down. So let me just write that note. Just put it on here, here. So we can say that when graphed, quadratic equations form parabolas. These are U-shaped curves. All right. Now, when it is that a is greater than 0, so we just put this here. When a is greater than 0, we have a U shape like this. And when a is less than 0, we have a U shape like this. This point here is called the vertex. All right, and I'm just going to write that in here, vertex. All right, that point there is called the vertex. And completing the square is nothing more than writing the quadratic equation in vertex form. And this vertex form is what we will use to figure out this vertex here, which we will do in later lessons. But for now, just know that when we're completing the square, what we're doing is we're rewriting the quadratic equation into a vertex form, and we're going to use that form later on to identify vertex, the vertex point. And as you can see, this vertex point looks like a maximum point here, and this vertex point looks like a minimum point here. So this is what we would tend to use it for. All right. The areas of interest that you would have with respect to a quadratic equation, as I already pointed out, one of them is the vertex. The other one is the axis of symmetry, right? Which is nothing more than the x location at which the vertex occurs. Then we have the maximum point, which is here, and we have the minimum point, which is here. And in this lesson, we will look about we'll basically be learning about the method used to obtain these areas of interest. And as I said before, it's called completing the square, or you would say write the equation in vertex form. Now, first off, you might want to ask yourself, why is it called completing the square? Let me just write that down. So why is it called completing the square? All right, so why is it called completing the square? It is a method used to rewrite the quadratic equation, as I said, in vertex form, right? So it is, let me just write this differently. Yeah, right. It is a method used to rewrite a quadratic equation in vertex form. And what is vertex form? Vertex form is of this form. We have a out in front here, then we have x plus h, close bracket squared, and then plus p. So our function will be written as something like this, right? That is vertex form. The name is just simply a method that comes from a geometric interpretation, right? So the name is just a method that comes from a geometric interpretation. So what we can do is we can do that, all right? So we can consider something like a square. So let's start off first this, and I'm going to draw here, and let's consider this square here, all right? This square, let me just put this off, right? This square is one that has x height, x width, and area x squared. All right. Now remember, your quadratic equation looks like this. It looks like ax squared plus bx plus c. Right now, we're just concerned with this part here, which is the x squared plus bx. All right. We're only interested in that right now. Okay. So we have first a square, side x, area x squared. Now suppose we want to add another area b of x, and I'm just going to simply draw this in blue now. So we have here, right? This here is going to have a height x and a width b. Right? If we were to take these two pieces and add them together, we can do something like this. We can break up this into two equal parts, and that would mean I would have a square that runs from here to here. And I can take that square that we have, which is this, and just simply put it over here. You know what? Let me give some space in between this. So I'm going to take this, I'm going to take this and put it out to the side over here, like that. I'm going to erase this. I'm going to put an addition sign back over here. Back an addition sign. And I'm going to take this square that we have over here and put it on the side here. All right? And then I'm going to take another one and put it on the side over here. All right? Now, all I did was I took this original one here and I split it in two pieces, and I took one piece and I put it here, and I took the other piece and I put it here. All right? So this has a width of b over 2, and this has a width of b over 2, but they have the distance x and x over here. So this here is, this first piece here is bx over 2, and this here is bx over 2, and when I add the two of them, I get this bx area over here. This little piece that's missing over here is what we need to figure out to complete the square. And if you notice, then you can see that this here is just simply b over 2 squared. All right? It's b over 2 squared. So this is b over 2 in height. This is b over 2 in width. So b over 2 by b over 2, b over 2 squared. So let me just write that outside here because it looks really small. So b over 2 squared. All right? Now, quadratic equations look like this. So we need to do the adjustments, and we need to rewrite it in such a way that we can deal with any type of quadratic, not just something that looks like x squared plus bx. All right? But it's the same principle. We're going to be taking this, splitting it in two, adding piece here, and then adding the squared piece on the underneath here. All right? So we're filling this gap, and filling this gap is what we call completing the square. So by filling the gap, we'll get something that is going to have a perfect square expression, and then we just simply need to manipulate it to form the vertex form. All right? So I'm going to outline some steps in which we can do this, and we'll see what's happening here. All right? Let me just put this on a text, and here, and we'll say steps to completing the square. All right? And first one, and I'm going to put it in white. First one is to factor out the coefficient a from the x squared term. I'm just going to write it like that, x to the power of 2, and x terms if a is not equal to 1. Right? The second thing we're going to do is we're going to divide the coefficients of x by 2 and square the result. Third thing we're going to do is we're going to apply additive identity by adding and subtracting the squared value. Yeah, the squared value to create a perfect square. Right? Inside the parentheses. Alright, while keeping the equation balanced. And then the fourth one, we're going to rewrite the expression into the perfect square, Q-U-A-R-E, and a constant outside the parentheses. Or basically, we're going to have the vertex 4. So when they ask you to complete the square, they're asking you about writing the vertex 4. So we're going to first try an example, and from there we're going to try a few, and then you'll get some to try for yourself. So example 1, we're going to say express f of x equal to x squared plus 6x plus 15 in the form x plus h squared plus k. Alright, so the first thing you want to do is you want to identify the function. So f of x is equal to x squared plus 6x plus 15. We need to first factor out the a term, but there's no a term here. This is 1, so we don't need to worry about that. Now we need to add and subtract half of this coefficient squared. So the coefficient that we have is 6 plus 6. We need half of that squared, which is the same as saying 3 squared. All right. Now I like to leave it as 3 squared. Okay. So you would write something like this: f of x is equal to x squared plus 6x. And then we're going to add 3 squared here. And we're going to minus 3 squared here. And then we're going to put back the plus 15. All right. Now we're doing this here because this is 0. If we add and subtract the same value, it's 0. All right. So we're not essentially changing the equation. This is what we meant by keeping it balanced. We're adding essentially, so I'm just going to circle that. We're essentially adding 0 here to the equation. If 0 is added, nothing changes. Okay, but what we're going to do is we're going to group it differently. We're going to take this here and group it by itself, and take this here and work it out by itself. Now remember, this here is perfect square form, right? That there is perfect square form. So I can write that f of x would be equivalent to x plus 3, close bracket, squared. And then I can resolve this piece at the end here, which is negative 3 squared, which is 9, minus 9. So minus 9 plus 15 is going to give me a positive 6. Right? And that's the end of that. We're already finished with the solution. Right? 15, 15, 15, 15, 15. Right, yeah. Plus 6. All right, let's try another one. This time, let's not have an a equal to 1. So example, right, so we're required to express f of x equal to 2x squared minus 8x plus 3 in the form of 2 into x plus h squared plus k. All right, let's solve this. So the first thing we do is rewrite the equation. And now that we rewrite the equation, we're noticing that we have a value out in front here like we didn't have before. So we're going to have to factor out that 2 from the x squared and the x coefficient. So we're going to have something looking like this. 2 into x squared minus 8 over 2, which is 4x, close the bracket, plus 3. Now what we're going to do, we're going to take this coefficient here, and we're going to say minus 4 divided by 2 is equal to minus 2, and we're squaring that. Okay, we're going to add and subtract that value. So we're going to have to add and subtract that value inside of the bracket. So let's write that over. So f of x would be equal to 2 into x squared minus 4x. And again, we're going to add negative 2 squared, and then we're going to subtract negative 2 squared, and then we're going to close the bracket off and add 3, right? Now, here's what's going to happen. We're going to see that this right away is following the completed square form, right? This right away here is following the completed square form. So we can say that this here would be f of x is equal to 2 into, sorry, not the completed square form, the perfect square form. So we're going to see that this is equal to x minus 2 squared, and then this is multiplying out by this here to give us a negative 2 squared is 4 by 2 is 8 plus 3. And then we work this out, and we're going to get that f of x is equal to 2 into x minus 2 squared, and then minus 5. All right? If you have any questions, you can ask me. Don't forget to ask me as you have issues. All right? Don't wait. All right, let's go to the next one. Example number 3. All right, so we're required to express f of x equal to negative 3x squared plus 12x minus 7 in the form of a into x plus h squared plus k. All right, so first off, we write down the function. Then we simply factor out the negative 3. Then what we do is we add the perfect square form, so we're looking at negative 4. We're going to get something like this. We're going to recognize that this is the perfect square form. And we're going to recognize that we have to take this and multiply this here. So Negative 2 by negative 2 is 4. This is minus 4. Minus 3 by minus 4 is positive 12. So we have positive 12 minus 7. And then we finish off plus 5. And that's the answer. All right, so we're going to stop here with this. I think you get enough practice already to see exactly what needs to be done. Again, remember that this is vertex form, and I'm going to give you 5 exercise problems to do, and we will solve these exercise problems tomorrow. All right, so problems x squared plus 4x plus 1. Then we have 3x squared minus 6x plus 5. Then we're going to have minus x squared plus 2x plus 4. Then we're going to have 4x squared plus 8x minus 7. Then number 5 is negative 5x squared plus 10x minus 3. All right, so these will be the problems that we're going to solve tomorrow before the next lesson. So if you have any questions, make sure to ask. Remember, I can't see you, so you need to make sure and ask your questions as you have them. I will answer them as soon as I see them. So enjoy the rest of your day, and I'll see you tomorrow for our next lesson.